We spent 290,000 years off the mosquitoes menu, then built ourselves onto it. If mosquitoes barely touched ancient humans, why do they kill hundreds of thousands of people every year now? The evidence is in mosquito genomes, the bones of Egyptian mummies, and a genetic mutation that tracks the spread of farming across a continent. Mosquitoes have been on this planet far longer than we have. They predate humans by hundreds of millions of years, and for most of our species' roughly 300,000-year history, they existed alongside us without making us their primary target. Our ancestors traveled in small, scattered bands across ground they knew well, and when the seasons shifted or a water source dried up, they packed up and moved. Nobody was storing water in clay pots or digging channels that could hold stagnant pools for months at a time. The conditions that let mosquito populations explode next to dense groups of people simply didn't exist yet. That doesn't mean malaria was completely absent from the ancient world. A 2026 study by researchers at the Max Planck Institute, the University of Cambridge, and the Natural History Museum traced how malaria shaped where humans could live across Africa for the past 74,000 years. They combined mosquito distribution models with paleoclimate data and found something striking. Humans consistently avoided areas with high malaria transmission risk, and that avoidance fragmented populations across the continent for tens of thousands of years. The disease already lived there, pushing our ancestors away from certain zones long before anyone planted a field. But malaria was already present 74,000 years ago, and the death toll was nothing like what we see today. The difference comes down to density and mobility. Mobile forager bands were small, usually a few dozen people, and they moved on before local mosquito populations could build up to epidemic levels. Picture a camp of temporary shelters near a seasonal waterhole, occupied for a few weeks and then abandoned when the group followed game to new ground. There was no permanent standing water, no dense clusters of bodies sleeping in the same spot night after night, no agricultural runoff feeding mosquito larvae. Sporadic exposure isn't the same as endemic, civilization-shaping death. Therefore, the claim isn't that mosquitoes never touched ancient humans. It's that the mosquito-driven death toll defining the last 10,000 years of human history was almost absent for the 290,000 years before agriculture. Something flipped the switch, and the question is what we did to flip it. If you like history explained through hard evidence instead of guesswork, subscribe now. This channel runs entirely on proof like this, and we're just getting started. The mosquito behind dengue, yellow fever, and chikungunya is called Aedes aegypti, and the form that bites humans is a recent evolutionary split. In 2014, a team led by Carolyn McBride published a study in Nature that collected two forms of Aedes aegypti near Rabai, on the coast of Kenya. One was a forest form that prefers to bite non-human animals, and the other was a domestic form that prefers humans. They are the same species, but the domestic form evolved to specialize in hunting people. The mechanism is precise. A single odorant receptor, called AAEGR4, became more sensitive to a compound called sulcatone, which is abundant in human body odor. And the domestic mosquito literally rewired its sense of smell to find us through that one genetic shift. This isn't a mosquito that always loved humans. This is a mosquito that learned to love humans, and the learning happened because we made it worth the effort. But a forest mosquito has no obvious reason to abandon its original hosts and start hunting people, because forest animals don't stand still in one place, don't gather in dense clusters, and don't store water in containers that sit outside their shelters. Humans, who settled down, did all three. When villages started storing water in clay pots, those pots became artificial breeding sites. warm and still and protected from the predators that lay eggs in natural forest pools. Dense villages meant a reliable blood meal walking past every few minutes. Therefore, the mosquito didn't choose us. We built the conditions that made specializing in us the winning evolutionary strategy. And it domesticated itself because we domesticated the ground beneath it. That same ground has stopped moving. The shelters are sturdier now, the water source is permanent, and clay pots sit outside every doorway. But the mosquito is only half the story. The other half is written into our own blood. In 1958, an anthropologist named Frank Livingstone proposed something that sounded strange at the time. The sickle cell gene, which distorts red blood cells and can cause a painful disease, reaches its highest frequency in West African farming populations. He argued the gene follows the spread of agriculture across the continent, not the other way around. Forest clearing for farming did two things at once. It created sunlit pools of standing water where mosquitoes could breed, and it packed people into dense villages right next to those pools. Malaria pressure spiked in those cleared zones, and the sickle cell trait protects against severe malaria, so the gene spread rapidly wherever farming created the right conditions. Genetic analysis reported in 2018 traced the mutation back to a single person in West Africa, roughly 7,300 years ago, and its advantage was a shield against malaria, which means the gene itself is young. But if the sickle cell gene looks like an ancient human defense against malaria, the timing tells the opposite story. The defense is recent, and the disease pressure that created it is recent. A gene that warps your own blood cells and can kill you in its inherited form doesn't spread through a population unless the threat it protects against is constant and severe. Before farming, there was no sustained, dense, year-round exposure to justify paying that cost. Therefore, malaria pressure itself is recent, tied directly to the agricultural transition, and the mutation's age works like a timestamp on when mosquitoes became our problem, stamped into the human genome. Think back to that settlement. The temporary camp has become a cluster of cleared fields, with irrigation channels cutting through the soil, and grain stores standing where the water pots used to sit alone. People are staying put through every season, and the mosquitoes are staying put with them. But West Africa wasn't unique. Just first, the same experiment ran again, on the Nile, this time preserved inside the mummies themselves. Egypt built the most famous irrigated civilization in the ancient world. The Nile flooded annually, and Egyptians engineered canals, basins, and drainage systems to control that water for year-round farming. And that same engineered water became the perfect breeding ground for Anopheles mosquitoes, the genus that carries malaria. In 2008, researchers led by Andreas Nerlich tested 91 bone samples from ancient Egyptian mummies and skeletons, spanning sites from Abydos in the predynastic period around 3500 BC to tomb complexes in Thebes used as late as 500 BC. They found Plasmodium falciparum DNA in 2 samples from the New Kingdom to the late period, both from adults whose bones showed evidence of chronic anemia. No positives turned up in the earlier predynastic or Middle Kingdom samples. A separate study examined mummies from the Fayum Depression, a region defined by its irrigation system and Lake Qurun, about 80 kilometers southwest of Cairo. 16 mummified heads dating from roughly 1064 BC to 300 AD were tested, and 6 of them carried Plasmodium falciparum. The researchers noted that the Fayum's canal network and land reclamation projects under the Ptolemies created exactly the standing water conditions that drive malaria. They also pointed out a modern comparison. Malaria incidence runs about 10 times higher in cereal farming areas than in uncultivated zones, because wheat pollen feeds mosquito larvae. But the earliest samples, from before large-scale irrigation, came back negative. The parasite appears in the record only after permanent irrigated agriculture is established, which means it looks like malaria always belonged to Egypt, but the molecular evidence says it arrived with the canals. Therefore, the civilization that mastered water engineering also mastered the mosquito's habitat without knowing it. The more they controlled water for farming, the more they built the breeding infrastructure for the insect that fed on them. That ground has become a proper town now, granaries rising above the rooftops, canals branching off a river that feeds regulated fields in every direction. But Egypt was just the opening act. One empire pushed water engineering further than anyone before it, and paid for it in its own bones. Robert Solaris spent years on this. His 2002 book, Malaria and Rome, builds the argument that deforestation, irrigated gardens, and stagnant water around Rome created ideal conditions for malaria because the parasite needs temperatures above 20 degrees Celsius to develop. And the cleared, watered Roman countryside provided exactly that, season after season. In 2016, a team including Stephanie Marciniak recovered roughly 2,000-year-old Plasmodium falciparum mitochondrial DNA from 2 adults buried in southern Italy during the 1st and 2nd centuries of the Common Era. This confirmed what historians had suspected but couldn't prove. Malaria ran through the height of the Roman Empire, written into the bones of people who lived and died under it. Roman water infrastructure was the most extensive in the ancient world. Aqueducts fed public baths, private gardens, and artificial ponds, while marshes around the city, including the Pontine marshes, were never fully drained. Standing water was everywhere, sitting next to one of the densest urban populations in history. And every aqueduct that supplied the city also supplied the breeding sites that fed the mosquitoes that preyed on the people who built them. But Rome's greatest engineering achievement sealed its own fate. The aqueducts and gardens that made the empire one of the most malarial places in the ancient Mediterranean were the same systems that kept it fed and watered. And the DNA in those southern Italian skeletons is the receipt. Therefore, the pattern is complete. West Africa, the Nile, and Rome all tell the same story across unrelated regions and thousands of years, backed by 3 independent evidence trails: mosquito genomes, ancient pathogen DNA, and the human genetic record. We didn't get lucky for 290,000 years and then get unlucky. We changed the ground, and the ground changed what hunted us. Return to that ground, one last time. It's a walled city now. Aqueducts arching over the rooftops, granaries stocked against famine, marshland spreading at its edges where the water gathers and waits. The mosquito didn't find us. We built the world it needed, and it moved in. If this made you think differently about the ancient world, subscribe. Subscribe for more of history's hidden causes. And if this one hooked you, the next video's already waiting for you below.